I want to talk about platform engineering, the latest, greatest trend in the world of DevOps. I can barely see the audience, but can we do a show of hands of how many people have heard about platform engineering? Oh, thank you. Wow. That's OK. And how many people are platform engineers? Oh, wow, awesome. OK, we got some of my people in the house. Yeah, so that makes sense. Google Trends suggests that platform engineering is as popular as it's ever been, and its popularity started rising in the last 2 years. There are SaaS companies now that sell platform engineering tools. Gartner says that platform engineering is a strategic trend for 2023, and they expect that 80% of organizations will have platform teams by 2026. Some people even claim that platform engineering replaces DevOps. You just have to Google DevOps is dead to find plenty of blog posts about platform engineering. So those are tall claims. How much of that is real? How much of it is hype? Is platform engineering the Dogecoin of DevOps, or is it something more substantial that you and your organization should invest in? So that's what this talk is about. It's roughly structured as the why, what, and how of platform engineering. We'll look at why DevOps adoption actually naturally leads to a need for platform teams, what developer experience with an internal developer platform could look like, and then we'll talk about how you can build your own platforms. This talk is not a tutorial. The only thing you're guaranteed to get after this talk is lunch. My only intention is to give you enough jumping off points so you can do your own research and then build your own platforms. So let's get into the why. The why is mostly about DevOps. As we have adopted DevOps culture and practices, we have shifted left. This is a popular visual for what shift left looks like. It basically says that traditionally concerns of quality and quality factors like performance and security have been in the later stages of a product's life cycle that is on the right. And it advocates for bringing these concerns earlier into a product's life cycle as we move from an inspect it later model to a build quality in model that is shifted towards the left. So if you're shifting things towards the left, it's worth considering who's on the left. Traditionally, these responsibilities have been split by dedicated functions. But with the adoption of DevOps, we want to move from an assembly line style of value delivery to a cross-functional team that owns your product end to end. So if you're shifting new responsibilities on a cross-functional team and asking them to own something end to end, with additional responsibility comes additional cognitive load. These teams have to learn new concepts, learn new tools. Product development teams can be found building test deploy automation, running security scans, performance tests, deploying the applications, and they're also expected to operate and monitor the applications. So DevOps shifting left, autonomous cross-functional teams is awesome, but it's not for free. We need to manage or invest to solve this additional cognitive load. Before I move on, cognitive load is like cholesterol. There's good cognitive load and bad cognitive load. Like Gabriel was talking about optimizing for germane cognitive load. This talks about the bad cognitive load, which is to the extraneous cognitive load. So every time I say cognitive load today, you can just imagine bad cognitive load. Right. The other thing that's great and not free is microservices, or more accurately, distributed systems. Traditionally, it's been the responsibility of operations to run applications that dev hands over, and also provision infrastructure, maintain and operate infrastructure for these applications. This is usually because the ops and infra functions are usually coupled. As we have adopted microservices and distributed systems, the number of development teams has scaled, so has the number of applications. So operations now finds themselves managing and running hundreds of applications, making sure the networking between them is not only secure but reliable, all the complexity of the hundreds of the databases, caches, and queues that these applications need as well. So the operational overhead on the ops team is growing exponentially. The ops team can respond to this by scaling, by adding more people in the team, but there's a limit to how many people you can add in a team before the team stops being effective. I don't know if any of you have seen maybe those 50, 100 mega ops squads, 50, 100 people ops squads in your organization. If you have, you can make your own decision about how effective they are. Now, because development teams depend on human intervention from these operation teams, these ops teams end up being a bottleneck to the flow of value for the organization. These teams end up being buried under a slew of service requests, and then they get buried under the maintenance and operations of the sprawl of the infrastructure they own. If you have seen a phase of delivery for your project, which is all about stability, or we need to stabilize this, you may have seen a symptom of this bottleneck. Right. So we come to these two seemingly irreconcilable factors, which is, on one hand, if you try to go for autonomous cross-functional teams that can own things end-to-end, you suffer from high cognitive load. And on the other hand, if you keep some of these responsibilities outsourced to a central team, you have an organizational bottleneck. This is how I like to build a business case for platforms. This is a non-exhaustive list of all the effects of these two factors on individuals, teams, and organizations. So it's basically everything that's the opposite of what Gabriel was talking about. If you have a dependency on a central team, you're going to have waiting and handoffs and meetings, which means time to value is going to be slow. If your feedback loops are slow and broken, then it also means your quality is not going to be great. Since developer time is your most precious resource, and developers are stuck struggling with high cognitive load and low-level complexity, it means that your costs of engineering are going to be high, and most probably motivation, innovation, retention, developer experience is going to be poor. And finally, because if you move responsibilities, end-to-end responsibilities to individual teams without enabling them, then you may end up with rework across the orgs. Each team is reinventing the wheel. They're reinventing the wheel slightly differently. So you end up with a spectrum of tooling, tech stacks, practices, and ways of working across the org. This kind of fragmentation makes showing compliance to a standard extremely hard, and it makes governance even harder. So to solve this spiral of doom of slow time to value, high cost, and low quality, what we need to do is try to flip dependency to autonomy while keeping the cognitive load manageable. And if we can do that, waiting may turn into self-service, developer friction turns into developer productivity, and perhaps the most underestimated impact of something like this is that if you enable autonomous team with reusable capability, you can get the benefits of standardization without the evils of centralization and bottleneck, which means that it's much easier to show compliance and do governance. I couldn't tell who to attribute this quote to, but it goes something like, make the right thing to do the easy thing to do. So to reverse that spiral and turn it into better software, faster, for cheaper, we need to aim for team autonomy while keeping their cognitive load manageable. So why platforms? Platforms enable autonomy by moving this ops team out of the way of product development teams. They do this by swapping ticket-based human intervention for self-service capability. And if this self-service capability is easy to understand and easy to use, that is, it abstracts away all the low-level complexity and keeps the cognitive load on the product dev teams low, then these product dev teams actually have an opportunity to be autonomous, cross-functional teams that can own their product end-to-end. i.e. they can actually be DevOps. Not just a team called DevOps, but a team that I can truly practice DevOps culture. So that's the why of platforms. Perhaps that's why Gartner talks about why 80% of organizations will have platform teams. And there's a wonderful blog by Charity Majors that's called The Future of Ops is Platforms. And my personal crystal ball also tells me that probably most organizations, the ops and infra squads, will move to a platform model. Right. Let's go into the what. What should platforms look like? Well, the best way we know what platforms should look like is products. Evan Bocher, in his 2018 article on martinfowler.com, it's called What I Talk About When I Talk About Platforms, describes platforms as a compelling internal product. His original definition is awesome. That's essentially, I think, the go-to definition for most people who talk about platforms. I encourage you to look up that article. Then the authors of Team Topologies, Matthew Skelton and Manuel Paez, I hope I pronounced their names correctly, or build upon the platform as a product concept, and they talk about what features of that product should be. Team Topologies has also inspired, in part, this visual. It's roughly, if you look at the Team Topologies book, you'll see something like this. But I won't give you spoilers. You can go read that book. So to paraphrase what Matthew and Manuel talk about, they essentially just say these 4 things, which is a platform should be curated to its users. Our users are internal developers or security functions or governance functions or even managers. It should help the users achieve their tasks easily, i.e. keep the cognitive load low. It should be optional. This is really key because it's your number one signal whether if you're building a platform that's useful or not. And implicitly, a product implies that it's self-service. So platforms as products. So what should platform products do? Anything that our users need. We take the most pressing and common problems of platforms, the most pressing and common problems of our users, and you address those problems in a way that it's easy for our users to solve the problem. As long as you're optimizing for autonomy and lowering cognitive load, everything is fair game for platforms. It could be service starter kits that bake in best practices in code organization. It could be infrastructure self-service, like let me provision a database without having to talk to anybody. It could be business platforms. Arguably, abstractions here are harder, but you can think of, say, a user onboarding service that everybody can just integrate with. It could even be knowledge. Gabriel was talking about user-developer onboarding. It could be things like making an onboarding journey for a developer much easier. Developers onboard to teams way more frequently than teams start new projects. So maybe this is a more pressing problem to solve. You can have observability platforms, pipelines as a service, data as a service, basically anything as a service, as long as it's addressing your users' actual needs. Right. So when I talk about platforms, I try not to talk too much about platforms. I like to show platforms. So in that spirit, in the spirit of products and platforms, let's look at what a specific user journey using a platform product could look like. So that's a user journey. Our user happens to be a developer. Developers are probably the most common users of internal platform product. And all a product developer wants to do is provision a database. It's a fairly common use case. You don't really need to read the rest of the text. So what would this look like without a platform product? Who likes Gantt charts? Nobody. Yeah, exactly what I thought. Did anybody? Oh, really? Why? I thought I'd spot maybe one project manager with this, but yeah, nobody likes Gantt charts. They never work out. So it's quite appropriate that we try to talk about what life looks like without a platform using a Gantt chart. So the product developers have two options if they want to provision a database. The first option is to outsource this request to an external team, or the second option is to DIY, do it themselves, or aim for autonomy. If they outsource this request to a team, they spend most of the time waiting for this request to be prioritized and then the database to be provisioned. And there's also the cost of coordination, talking across separate functions, handoffs and meetings. All of them come at the cost of context switching and time and cognitive load. The other option is quite tempting. I say, everything's using the cloud now. I don't need those ops folks to do it. I'll just do it myself. And it feels easy at first until you run into networking configuration, encryption, what key should I use, how do I set up password rotation, backup and restore option, and then the compliance team comes knocking, asking about some other configuration. So you realize that by trying to do it yourself from scratch, you are facing excessive cognitive load. So we are back at an irreconcilable trade-off of autonomy and cognitive load. So what would it look like with the platform product? So it starts with a user logging into an internal developer platform. What you're seeing here is a quickly set up demo platform that we use to talk to partners and customers about what platforms can do and can look like, and we use internally for experimenting with developer experience and self-service automation. It's basically the portal is built on Backstage. Most of the infrastructure provisioning is orchestrated by Terraform. Everything's running on Kubernetes, other than the database you'll see. And all of that is running on AWS. Right. Our product developer owns an application. This application is called the XConf demo application. You see it pop up. It's quite small, but I'll click through it in a bit. So this is the application that they would want to provision a database for. So if a user clicks through to the application, they see some details that you can safely ignore. And then they click through to what the deployed application looks like in a pre-production environment, says XConf demo, but all you really need to care about is that the application self-reports that it's using a local SQLite database. Shout out to my colleague, James Scott, for creating the service template from which this application was born. So that's what we want to do. We want to switch this application from using a local database to using an external Postgres database. So since a user wants to create a database, they navigate to the Create menu. On the Create menu, they can see a suite of platform offerings that are available to them for self-service. They filter down to the infrastructure resources that are available to them, and then they zero in on the Postgres database resource that they're interested in. On the next page is the most interesting page, despite what it looks like right now. This is the page where they need to input some configuration on to provision, to self-service this database. And what you'll notice is that our user is only asked for 4 lines of configuration. The first 2 are just implementation detail, name the database and what version of this resource you want to use. And the other 2 are details about the database itself. This is the minimum set of configuration that we can expect a product developer to reasonably understand and own. All we're asking them is, what major version of the database would you like to use? And all we're asking is, how much compute do you want to provision? Arguably, product developers are the ones who know what kind of queries they're going to run, how much traffic they're going to drive through the application to the database. So they're in the best position to decide how much compute to provision. The platform team, on their part, has abstracted away all the underlying complexity of networking, compliance, encryption, security, and all the things that product teams would not be able to answer, and if faced with, would only increase their cognitive load. Of course, this is not prescriptive. This is just a demo. How you design these interactions or interfaces for your platform products depends on what your users want to achieve. Maybe users at your organization want to control at what time of day and what day in the week the database should back up. So you hand that control off to the product teams. So again, this is just a demo. So a user selects the instance size that they want to provision. They point to the XConf demo app to which they want to attach this database, and they click next. And iMovie magic, 10 minutes later, we are back in our XConf demo application. We click through to it. And on this application, you can see that it's now self-reporting that it's using an external database. So I've omitted one part where the product developer does need to push config or change to actually tell the application, oh, here's another database, use this connection string to talk to it. But largely speaking, this is what a developer experience for with an internal platform product that enables autonomy and while keeping the cognitive load low could look like. Doesn't have to look like this, but this is what it could look like. So it's up to you to imagine what it should look like for your organization. That covers the what. How much time? All right, we have plenty of time. So let's go into the how. We can build platform products that look something like this. Platform teams usually sit between the underlying cloud provider layer, SaaS providers, and the product teams or application teams that need to use their offerings. So a platform team can use their, we're going to talk very specifically about the example that we just demoed so that it's easier to contextualize. So that's what we're talking about when we're talking about how we can build a platform product. It's just talking about this specific use case. Right. So a platform team can use their infrastructure as code tooling of choice and describe a database resource. Not only that, we know that they should abstract and opinionate this resource with all the underlying complexity that we want to abstract away from the product team. How this happens is by the platform team collaborating, talking, empathizing with its users and other stakeholders like compliance and security. So the journey to building a platform doesn't start with X as a service. It actually starts with strong collaboration. Finally, they need to add some documentation so that the product application team can discover this resource, understand how to use it, and use it independently. Now, let's bundle that all into resource called database resource version 1. And now we need to think about how can, now that this resource is defined, how can we offer it to our product application teams? Well, there are few ways. I'll talk about two today. The first of the two ways is essentially package management or as a software library. So depending on your tooling, infrastructure as code tooling, you bundle this resource into a package or a module, and you publish it to a known registry repository. And the application product team defines their own infrastructure as code configuration, but instead of configuring low-level details, they just discover and consume your model. That's easy enough to find, easy enough to use, easy enough to understand. There's plenty of tooling that will let you do this. Terraform is arguably the most popular. And as of now, if you Google Terraform self-service, this is the cloud operating model that they sort of recommend. Right. So as a consultant, it's my day job to advise people how to solve their problems. And as a consultant, it's my hobby to spend at least half the time talking about how you should not solve your problems. So don't do this. You can enable self-service with this, but in my personal experience, it usually goes wrong. To the folks taking pictures, this is what I'm recommending you don't do, just to be clear. So there's plenty of opportunity to go wrong here. It's because, one, your infrastructure as code tooling is coupled between your platform team and your product team. So maybe you expect your product team to write Terraform, which is doable. Or you can try to solve that by using CDK and Pulumi and write your platform team defining infrastructure in a software language that the product team is more familiar with, like TypeScript. Or hopefully Golang, since I'm expressing personal opinions. But so there's that coupling. The other thing is also, for some reason, infrastructure as code, folks over the last few years haven't got obsessed with DRY, don't repeat yourself, and keeping your configuration reusable. But what that ends up doing is you end up aiming for flexibility in your modules rather than single purpose. And you can overexpose configuration by trying to create one database module that can be MySQL, Postgres, and everything else under the sun and can do all sorts of configuration. And you think you've written a great module that can do everything, but it's actually really hard for your consumers to understand and use. For example, you can consider the open source models, Terraform models, which are great for infrastructure folks to use, but they would make extremely bad examples in this use case, because they just expose every single underlying cloud provider configuration. That's not what we're trying to do. And finally, the product team still has to own the runtime for the infrastructure as code tooling. For example, who will do the Terraform validate plan and apply for the root configuration that the product team wrote. You can solve that by writing more tooling. But these are considerations you need to make by going down this route. You can still go down this route. I think the right answer is always it depends. But you have to take these considerations into play. So the other approach is as an API. And the most popular way, and presently my favorite way, I hope this ages well, is by extending the Kubernetes API. How this works is by using or creating custom operators and defining your infrastructure as custom resource definitions. What this essentially looks like is, like you can do kubectl apply pods.yaml to tell a vanilla Kubernetes to create containers. An extended Kubernetes, you could tell kubectl apply database.yaml and knows how to create an external database for you, because that external operator knows how to talk to, for example, the AWS RDS API and make that happen. There is tooling available for you to try this out and experiment with it. The tooling is maturing, I think, on this front. Terraform and Pulumi both have their operators. AWS is building their own. And Crossplane is built natively for this kind of pattern. There is also some tooling that lets you create self-service infrastructure catalogs that is outside the Kubernetes ecosystem. I'm more familiar with AWS, so the tools that I'm aware of are Proton and Service Catalog. But since we're talking about extending your cluster API to expose infrastructure products, let's come back to that. So now, as a platform product developer, I can create a suite of platform infrastructure offerings. I can offer caches and databases. I can even define composite resources that are not tied to a single underlying cloud provider resource. They're composite. They can be whole environments with networking and compute and databases and everything. And they could share operators or have specific operators for each. And let's hide this operator and CRD complex implementation away and just now focus on how application or product developers can interact with this API to consume this infrastructure resource. OK. Show of hands, how many folks are product developers or software engineers? I'm at XConf, right? Can we have the lights up for a quick second? I have too much time to kill. So, right. OK. So keep and now put up your hands if you, for your day job, have used or used the Kubernetes API. Maybe it's just debugging things. Maybe it's just saying, apply this pod or deployment YAML. Maybe it's writing a Helm chart, or maybe it's some kind of GitOps flow you do to deploy your application. OK, so quite a few people. I'm going to say quite a few because you guys can't validate what I'm saying. That's the best part. The best part about this, and why this is presently my favorite, is because it allows you to meet your users where they already are. Quite a few developers are familiar with interacting with cluster APIs, and there are 1,000,001 ways in how you can interact with this API. You can write your Helm charts. Maybe you're a masochist and you enjoy pain, so you write your YAML files by hand. Maybe you use customized Argo Flux or some kind of GitOps flow. Any of these interactions that you've already adopted in your organization, you can use to now power infrastructure self-service. It doesn't really have to look like a developer portal or a GUI or anything. So that's why I really like it. There are definitely some challenges to doing this as well, but maybe that's for later. So what you can end up with is now designing developer portals. All my portal was doing was templating a Kubernetes YAML file and throwing it at the cluster. And then the database gets created. You can have CLIs. Maybe you can wrap kubectl into your own custom CLI, give your developers a Heroku-like experience. Or you could have GitOps flow, and people just do git push, and then your infrastructure gets provisioned. So you can end up with something that looks like this. You have a platform orchestration tooling that you use to define your infrastructure platform offerings, and you have a developer experience and platform interface that's powered by a cluster API. So that's all I had. To conclude, platform teams should aim to reduce cognitive load and optimize for autonomy. If you're convinced that platforms is the way to go, maybe you could use the impact of high cognitive load and organizational bottlenecks to try to build on getting buy-in from management. If you're lucky enough to already have buy-in from management, then maybe you can think about applying product thinking to your platforms. And if you're thinking about how do I go about implementing infrastructure platforms, maybe you can consider building a platform developer experience interface on top of self-service APIs. Right. Thank you very much. I usually only talk about platforms, so if you want to talk about that, that's my LinkedIn. I hope you enjoy and get to build your own platform.